All right, example 2. This should be fun. So, looking at our differential equation, once again we see that it is non-homogeneous because it is set equal to cosine 2x. Now, if we remember, when it's set equal to cosine of 2x, our y of p is going to be equal to a cosine of 2x plus b sine of 2x. And I'm just going to leave that to the side because I want to first find a complementary solution. So I want to find y sub c. So I'm going to set this differential equation set equal to 0. 4y double prime minus 4y prime minus 3y equals 0. I'm going to substitute in again for my derivatives. So 4m squared minus 4m minus 3, set that equal to 0. And then, again, I'm going to factor. Now, when I factor here, I'm going to get 2m minus 3 and 2m plus 1. Set that equal to 0. So I have my 2m's. I have my m as negative 1/2 and my other m as positive 3/2. So I found my y sub c. My y sub c is going to be c sub 1 e to the negative 1/2 x plus c sub 2 e to the 3/2 x. Now to find the particular solution. To find the particular, we again, once have our y sub p already, we need to take the derivative so that we can determine our coefficients. So we have y prime of p equals, take the derivative a cosine 2x, is going to be minus 2a cosine 2x. Derivative of b sine of 2x is going to be 2b cosine of 2x, and this should be sine, not cosine. And then take the derivative one more because it's set to the second derivative there. So do y double prime, and we're going to get negative 4a cosine 2x minus 4b sine of 2x. And so there we have our derivatives, and we're going to substitute those into our differential equation. So there's a lot to substitute in. So we're going to get 4 parentheses negative 4a cosine 2x minus 4b sine of 2x minus 4y prime, which is going to be negative 2a sine 2x plus 2b cosine 2x minus 3y, and we get a cosine 2x plus b sine 2x, and that's equal to, now I'm going to set this equal to cosine of 2x plus, we want a sine there, and we want our sine of 2x, but it's not really there, so the coefficient for this is really 0. And I'm going to just keep that right there so that you can see 0 sine of 2x. And now, we're going to combine everything that we can, so I'm going to go ahead and multiply where I need to multiply. 4 times negative 4 is going to be negative 16a cosine 2x. 4 times negative 4, negative 16b sine of 2x. A negative times a negative is a positive, so plus 8a sine of 2x minus 8b cosine of 2x. Distribute the negative 3, negative 3a cosine of 2x minus, distribute negative 3, minus 3b sine of 2x equals cosine of 2x plus 0 sine of 2x. And now, When I combine all this, I want to keep all my cosine of 2x the same together and all my sine of 2x the same. So I'm going to look at this. I have a negative 16 cosine 2x, and then I have a minus 3a cosine 2x. So I'm going to combine those and make that negative 19a. And I also want to keep my other cosine 2x, which I have right here, is a minus 8b. So I'm going to write minus 8b, and these are all of my cosine of 2x's. Now the reason why I want that is because this is my coefficient, which I can match over here. So now I'm going to combine all of my sine of 2x's, and here I have an 8a, so I have 8a minus 19b sine of 2x, and that's equal to cosine 2x plus 0 sine of 2x. Now I'm going to set my coefficients equal to my coefficients over here. So negative 19a minus 8b is set equal to 1, because those are for both cosine of 2x's. And then 8a minus 19b is set equal to 0, because that's the coefficient of sine of 2x. Now here, I set this up to where I can do an elimination method. And so what I'm going to do is I'm going to add these two, and it looks like I could get rid of the a's pretty easily. So I'm going to multiply the second equation all the way through by 19 over 8 to eliminate everything. When I do this, I'm going to get negative 425 over 8. B is equal to, add those, is equal to 1. And then to get rid of the negative 425 over 8, I multiply both sides. So I found B. B is equal to negative 8 over 425. Now to find A, all I need to do is to substitute that in. So I'm going to substitute my B into one of these equations. I'm just going to head to substitute into the top equation. So negative 19a minus 8 times negative 8 over 425 equals 1. And when I solve for A, again, most of y'all can solve a two-step equation. A is equal to negative 19 over 425. And so my y sub p is going to be equal to, if you recall from up here, it's a cosine of 2x. So it's going to be negative 19 over 425 cosine of 2x plus b, in this case it's minus 8 over 425 sine of 2x. And there's the particular solution for the differential equation. Now, I want to write the general solution, so I'm going to combine my y sub c and my y sub p. So the general solution is just going to be y equals c sub 1 e to the negative 1/2 x plus c sub 2 e to the 3/2 x minus 19 over 425 cosine of 2x minus 8 over 425 sine 2x. All right, and that completes that equation. Now, the next equation is going to be like a little lesson in this. All right, we're going to try to solve it the same way, and you're going to see that not everything is going to be done the same, and then I'm going to show you why that's not the case and just how to fix that. All right, so again, we're going to work on y double prime minus 16y equals 2e to the 4x. So again, it's non-homogeneous, and so we need to find a particular solution and a complementary solution. So now, initially, our y sub p, since this is just 2e to the 4x, should just be a e to the 4x, where a would be our undetermined coefficient. So let's find our particular solutions. Let's find our complementary solutions first. And so I'm going to change up colors a little bit. And I'm going to say that, okay, this is going to be m squared minus 16 equals 0. Well, that's nice. It's just going to be m is equal to plus or minus 4. And so our complementary solution is going to be c sub 1 e to the 4x plus c sub 2 e to the negative 4x. All right. Now, hopefully you see that I already have a solution where I have a constant e to the 4x. And here, my particular solution, I'm saying I have a constant times e to the 4x. So they match, all right? So when I actually try to solve this one, I'm going to plug in y sub p and do now y prime of p, which is going to be 4a e to the x, 4a e to the 4x, y double prime of p, and that's going to be 16a e to the 4x. And so then I plug this in and plug it back into this formula, and I'm going to get y double prime, which is 16a e to the 4x minus 16 times a e to the 4x, and that should equal 2e to the 4x. Well, there's a problem. The left side equals 0, and we get 2e to the 4x. Now, why is that? Well, the reason is because we already have the solution, and if you remember back in the last section when we got the same m twice, where m sub 1 equaled m sub 2, all right, and say they both equal 2, then instead of saying e to the 2x, you know, this would be m sub 1. Instead of saying that's the solution, say like y sub 1 is that, then our y sub 2 would be x e to the 2x. So whenever there's going to be a repeat of a solution, then we need to multiply it by an x. So instead of saying y sub p a e to the 4x, what we're going to do is we're going to say our particular solution is going to be a x e to the 4x, because we already have an e to the 4x as a solution. So we check our y prime of p, and we take the derivative, and we get 4a. Let's take the derivative. Now, this is not fun because this is going to be a product rule. Derivative of x is just going to, derivative of ax is just going to be a, so a e to the 4x plus derivative of e to the 4x is going to be 4a x e to the 4x. And then now let's see y double prime of p. And the derivative of a e to the 4x is going to be 4a e to the 4x plus derivative of this is going to be another 4a e to the 4x plus 4 times 4, so 16 ax e to the 4x. I'm going to simplify that, and we're going to get 8a e to the 4x plus 16a x e to the 4x. And now we're going to solve, and we're going to set it equal to our 2e to the 4x. So we're going to plug back into y double prime. So we get 8a e to the 4x plus 16ax e to the 4x minus 16y, which is ax e to the 4x, ax e to the 4x, and that should equal 2e to the 4x. And what you're going to see is, what's going to happen is our a to the e x, ax e to the 4x's are going to cancel out, and we're left with 8a e to the 4x is equal to 2e to the 4x. And now we're going to set our coefficients equal to one another. So 8a should equal 2, so that means that a is going to equal 1/4. So our y sub p is going to be 1/4 x e to the 4x. And so our solution, y equals c sub 1 e to the 4x plus c sub 2 e to the negative 4x plus 1/4 x e to the 4x.